Hey all, let me welcome you to the second installment of our webinar series. We're coming to you live from the third floor of the lovely City Point building here in the heart of the business district of Prague, Pankratz. If you have any questions, please feel free to drop them in the chat, um, and we'll be more than happy to get them at the end of the webinar. Jan is here with me to
Hello.
discuss our topic for today, how to develop applications in the cloud and keep your feet on the ground. Jan?
Hello, everyone. Development for cloud is actually a hot topic for many companies today. And one could say it's the same programming as decades back when only owned computers were used and the cloud is just the computer of someone else. But that is just a one-sided view.
Okay, great. So just before we begin, I'd like to take a quick poll. How many of you are already using cloud native architecture? Please just reply in the chat and I'll go through the results later. Anyway, while we wait, Jan, I'd like to say some things have changed, wouldn't you?
Yeah, sure. In reality, more than a few things changed. The most significant shift we can see in the pace is in the pace of software delivery, while the complexity and functional scope is constantly expanding.
Yeah, that's definitely a huge challenge. Is there any standardized approach to resolve that?
Fortunately, yes. The best known really working approach is cloud native architecture and technologies.
So does that mean that such applications have to run in the cloud?
Not necessarily. Such applications could be deployed and operated within your data center
Mhm.
or in on private or public cloud as well.
Okay, so let's dive in and get some more insight. What is cloud native about?
Sure. Let's have a look at the goals of cloud native first. One of the most important goals to support business is a controlled way of software delivery, which means to improve the predictability of releases. An appropriate approach to achieve such an improvement is to shorten a release cycle uh, uh, and decouple the releases of components at the same time.
All right, got it. So such an approach must result in significantly decreased scope of a single release, right?
Exactly. The less things you have to change, the less chance of a failure. While such a shift is necessary, it would not be enough without ownership improvement of the things, which seems to be an easy and natural evolution, but in fact, this is a key success factor.
So can you please elaborate on this? What do you mean by that?
That means to really carefully architect the scope of responsibilities of the components and the teams as well. To minimize an opportunity to excuses and to support the liability arising from ownership of the whole team or teams. Such a change leads to shortening of time to fix an issue, especially in production.
Can imagine that's a huge advantage of such an approach. Are there any other goals of cloud native?
Definitely. Cloud native doesn't end up with the development only. It covers operation of the solutions as well. In this area, the goals are not any less ambitious. Resulting applications should be almost endlessly scalable, which is important, especially for the fast-growing businesses. But at the same time, the applications have to be more resilient as well, which is leading into higher availability. All this is achieved and supported by component mobility. Uh, by the way, such mobility also means that your application is cloud agnostic and is not bound to any particular cloud service.
Sounds great, but it sounds a bit too good to be true.
You are clever. There is always a price you have to pay somehow to get all the benefits. In this case, there are two areas to solve. One is architecture related, uh, to design appropriate scope of components and teams. We will discuss those in a bit. The second area is something already standardized. Uh, this part you have to think hard, but the rest you can automate.
Okay. Why waste time with it when you can buy it? I mean, so Gartner calls it a value stream delivery platform, or VSDP. Our CodeNOW platform is the best example of it.
You're right. And if you would like to know more about cloud native development, Google for the 12-factor application methodology. By the way, the whole CodeNOW platform is purely based on that foundations.
Okay, okay. Perfect. So let's assume we automate what's possible and we'll focus on the development part.
Sure. Architecture and development of the software solutions are the only parts which cannot be automated. At least for today is the truth. However, there are attempts to automate development as well, and my personal opinion is that for certain cases they will be successful in the end. But back to your call. Focus on architecture and development. It's important to say that the approach you choose for that is also affects the outcomes of the automation you can get as well.
So you mean that the wrong approach, I wouldn't be able to get all the benefits we mentioned?
I would not call it the wrong approach. There is rarely something black and white in software development. Our experience indicates that the more flexibility you need in terms of time to market or scalability, the more fine-grained components you have to build.
Okay, so what's the issue? Why not design the finest grained components from the very beginning?
That might seem like a good idea, but usually leads to huge troubles, well known as big ball of mud. In the past, the term was spaghetti ball. With microservices, the mud is more descriptive. The worst thing about that is such evolution is much faster than with monolithic applications. The message here is, if you are experienced with microservices and know why you are doing it, it's fine. If you don't need such flexibility or don't have such strong experience, then it's better to start with a well-structured monolith. Such an approach usually leads to good high-level breakdown and allows you to refactor certain parts of the monolith into microservices later on.
That's a good point. I'm sure we'll come back to that a bit later, but could we elaborate on microservices now? What are the most important aspects of them?
This is a good question. The most important aspect of microservices is the split of the overall scope into small pieces and their isolation to the outermost limit. There are a couple of handful principles that are helping to achieve this. First principle is the isolation of the microservices, which means to break the strong coupling of the services, which is caused by the synchronous communication. Microservices communicating over a process boundary using asynchronous message passing enables the level of indirection and decoupling necessary to capture and manage failure, orthogonally to the regular workflow using service supervision. Isolation between services make it natural to adopt continuous delivery, and this allows you to safely deploy applications and roll out and revert changes incrementally, service by service. Isolation also makes it easier to scale each service, as well as allows them to be monitored, debugged, and tested independently, something that is very hard if the services are all tangled in the big bulky mess of a monolith.
So isolation improves resilience, the ability to heal from failure.
Exactly. And the next important aspect of microservice is autonomy. An autonomous service can only promise its own behavior by publishing the protocol, the API. Embracing this simple yet fundamental fact has a profound impact on how we can understand and model collaborative systems with autonomous services. Another aspect of autonomy is that if a service only can make promises about its own behavior, then all information needed to resolve a conflict or to repair under failure scenarios are available within the service itself, removing the need for communication and coordination.
I understand that, but what's the real value of autonomy?
It's in the working uh, with autonomous services, open up flexibility around service orchestration, workflow management, and collaborative behavior, as well as scalability, availability, and runtime management, at the cost of putting more thought into well-defined and composable APIs.
Okay, got it. So the goal of autonomy is to minimize any backdoor interventions on the microservice.
Exactly. And there is one more related principle to this, which is own your state. Up to this point, we have characterized microservices as a set of isolated services, each one with a single area of responsibility. And this forms the basis for being able to treat each service as a single unit that lives and dies in isolation, which is a prerequisite for resilience and can be moved around in isolation, which is another prerequisite for elasticity. While this all sounds good, we are forgetting the elephant in the room, which is the state. Microservices are often stateful entities. They encapsulate state and behavior in similar fashion to an object or an actor, and isolation mostly certainly applies to state and requires that you treat state and behavior as a single unit. Unfortunately, ignoring the problem by calling the architecture stateless, by having stateless controller style services that you are pushing their state down into a big shared database, like many web frameworks do, won't help as much as you would like, and only delegate the problem to a third party.
Those are pretty strong principles, but I would say they depend on the granularity of a microservice. One extreme is to put everything into one bucket. I wouldn't call it a microservice after that. Is there some indication for the other extreme?
Yeah, this is also important to mention. There has been a lot of discussion about the true size of a microservice. What can be considered micro? How many lines of code can it be and still be a microservice? But these are all wrong questions. Instead, micro should refer to scope of responsibility. And the guiding principle here is the Unix philosophy of single responsibility principle. Let it do one thing and do it well. We can see the trend of this more than 50 years old idea coming back nowadays. It has been abandoned with the growing scope and complexity of the applications because the delivery and operation of such fragmented solutions was very complex and expensive at the end. But with increasing automation, such concerns are not valid anymore. And thus, architects and software developers are looking back at the advantages of single responsibility principle.
Seems like the software development industry is starting to succumb to fashion trends.
It may look similar based on the appearance, but I believe that in this case, the trends are much more based on a reason than just a kind of feeling. The last principle I would like to share today is the asynchronous message passing. We have already touched this topic, but it's really important. An asynchronous boundary between services is necessary in order to decouple them and their communication flow in time, allowing concurrency, and in space, allowing distribution and mobility. Without this decoupling, it's impossible to reach the level of compartmentalization and containment needed for isolation and resilience. Asynchronous and non-blocking execution and input-output operations is often more cost-efficient through more efficient use of resources. It helps minimizing contention or on shared resources in the system, which is one of the biggest hurdles to scalability, low latency, and high throughput.
Okay, thank you for sharing them. Unfortunately, there's not enough time to have a look at some typical examples, but that might be a good topic for one of the next webinars.
Sure.
So I think we have to spend some time with the outline, how to integrate the manual and automatic worlds we've just explained.
This is more important than it might seem at the first sight. In fact, it has been found useful to apply some of the principles to teams as well. One of the most important is autonomy of the team. Let's imagine the situation from the monolith world. If the services would be operated by another group of people, even using heavy automation, in case of any issue, it would take ages to resolve it properly. That is one of the reasons why the team should be responsible for development, testing, and operation of the services it has in the scope.
Is that where DevOps culture came from?
Yeah, this has been the major driver for it. In order to collaborate effectively, developers and operations staff need to be able to make decisions and apply changes without convoluted decisions-making processes. In order to ensure that changes in production are sound, the team needs to value building quality in the development process.
Okay, so that's pretty clear. I just can't imagine how to define the team.
Now you hit the nail. This is exactly where most microservice architecture attempts are failing, especially on a larger scale. First rule is very straightforward. One service is managed by exactly one team. No sharing here. The best seems to build the team around the business product. If the team is fully responsible for product end to end, this is an optimal situation.
I would bet in the real world it would look a bit different.
Sure, in the real world, the complexity of the product is often beyond the capacity of one single team. And also you need to utilize some cross-product services like customer management, sales, finance, and so on. So practically, it's normal to have dependencies between components and applications and teams as well. In the real world, it's not possible to avoid such dependencies. Important is to set up scope of the teams in a way where dependencies will be loose and will not be circular. In such a case, you have to manage all the teams in the loop as a single team instead of having them autonomous. In fact, design of the team structure is part of the architecture as well. I remind you on Conway's law, which is saying any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. This statement has an imminent meaning in the context of microservices. As I mentioned before, in the microservice world, everything evolves faster, which means you will shortly end up in an architecture which is fully aligned with the organizational structure instead of your original setup design. And in this particular case, it means the structure of the teams. I feel it's important to mention here some basic classification of the teams. So basically, you can have a stream-aligned team, which is a value delivery team, typically mentioned business product delivery team, which is autonomous and cross-functional. Another type of the team is a platform team. Platform team is usually responsible for platforms that abstracts away infrastructure and networking or any other cross-cutting capabilities. And such team supports stream-aligned teams in delivery. Third type of the team is enabling team. Enabling team is making suggestions on tooling, practices, frameworks, methodologies, which increase autonomy of stream-aligned teams and help them to acquire missing capabilities. And the last type of the team is the complicated subsystem team, which aims to reduce cognitive load of the stream-aligned teams by delivery of complicated subsystems that require specialized knowledge, like face recognition, risk assessment, or things like that. And between those four kinds of teams, there are three basic interaction types. First one is the collaboration. Teams are working closely together to support rapid discovery and innovation. Second one is anything as a service. One team needs to use a code, library, API, platform, whatever. And this is important to achieve the predictable delivery. And the third type of the collaboration is facilitation, which is an active help to enhance productivity, effectiveness, and flow of help receiving team. The last thing I would like to mention is that there is a set of patterns how to resolve issues in team topology, even to reverse the dependencies if necessary. You might have heard about about the anti-corruption layer, sharing a shared kernel, published language, and so on.
Seems to be a huge topic in the end. So I don't expect it was so extensive. I didn't expect it was so extensive and important. Maybe a topic for one of the next webinars.
Sure. There is a set of tools which could be successfully used to elaborate microservice architecture and supportive teams topology. To name a few, the event storming, bounded contexts with context maps, and already mentioned teams topology as well.
Okay, great, excellent. So, of course, I have to mention we're very excited to tell you all about CodeNOW. Within a single platform, we're covering cloud native application, the only sustainable development technology of the future, supporting, building, delivering, and operation of microservices, CI/CD automation, all with no lock to a single cloud. You can check it out or trial it here. We'll go ahead and drop the link in the chat. For the next 15 people who sign up for the demos, we'll give you a 50% discount for 3 months on up to 5 seats. Please just sign up at codenow.com/try now and mention that you were here at the webinar. Basically, if you were to use those 5 seats, that's a $2,600 value over 3 months. So also, don't forget to check out our webinar for next month. We'll go ahead and drop the link in the chat here as well. So do we have any questions or anything from anybody?
Seems to be a lot of questions. Yeah, the session is recorded and will be available on the LinkedIn page for the future, so you can come back as you would like. And I think we don't have any other questions so far.
Okay, great, excellent. So, I'm Martin Wagner. Happy that you were all able to make it today. Feel free to, reach out to me on LinkedIn. I'll be more than happy to send you a recording of the session if you weren't here to make it for the whole thing. But I really appreciate everybody taking the time to join us, learn about cloud native application development, and we're looking forward to seeing you next time.
Thank you very much. See you next time.
All right, thank you.